My name is Eric Johnson, and I am a Senior Developer Advocate from AWS. I'm glad you're here. I'm sorry I'm not, and I appreciate your patience. I would like to give a shout out to the GOTO Oslo team on how they approach this in switching it to virtual. For those of you who made it, I'm excited for you. For those of you who couldn't make it and doing this virtual, I hear you. Same thing. I'm coming to you live from northern Colorado, and looking forward to sharing this. I hope that this is worth your time on watching my deck on thinking asynchronously. So let's get started. All right, first of all, a little bit about me. Again, my name is Eric Johnson. You can find me on Twitter at EDJGeek. I'm a senior developer advocate at Serverless in AWS, or for Serverless at AWS. I'm a serverless tooling automation geek. I've been doing serverless since it was announced in 2014. I love serverless. When I first saw it, I thought, wow, why would anybody do anything else? I believe it is the future. I believe it is going to help people be more secure, be more scalable, reliable, all kinds of advantages here. I've been a software architect and solutions architect since 1995. I am old. I'm an old fart. There's just no two ways around it. I'm a husband and a dad of 5. That is not a typo. I do have 5 kids. I'm a music lover. In fact, my original degree is in music. I thought I was going to be a professional drummer. Turns out I'm a fairly average drummer. Nobody's going to pay me to do it. And I'm a pizza and Diet Dr. Pepper fanatic. If you are daring enough to follow me on Twitter, again at EDJGeek, I talk a lot about serverless, but I also talk about pizza and my family and why pineapple shouldn't be on pizza. And if I were to ask you to raise your hand, I know everybody would raise their hand in support of the fact that pineapple absolutely shouldn't be on pizza. But that is not what we're here to talk about. So let's get to the point. Let's get to what we're here to talk about. We're going to talk about serverless patterns and how to make them more reliable, how to take advantage of the managed services to make them work for you. So let's talk about some common serverless patterns. When we're building websites, and now there's a lot of different things you can use serverless for. We're going to talk primarily about websites today, but this pattern again can be applied in a lot of different places. But when we're building websites, and specifically backend for websites, we use a common pattern where we'll have an API tier, a compute tier, and a storage tier or layer, or however you want to talk about it. And so with that, what we'll do is we'll say, okay, we've got at our API, we're going to handle our security and our routing. Then we're going to jump over to our storage, and that's going to handle our, storage. Pretty self-explanatory, right? But in the middle, we have our compute. And what do we do at compute? Well, pretty much everything else, right? So we look at applications, and a lot of times I see, people are handling their authentication, they're handling throttling, they're handling caching, they're handling, the compute is kind of the kitchen sink. Everything's put in there. Now, the issue with this, and this is the order that we do it, we say API, compute, and storage. But if something is going to go wrong, this is the most probable place. All right, let me explain what I mean by that, okay? You may say, well, why? Well, here's the why, okay? The why is because it is my code. Now, you may be saying, yeah, but my application isn't your code. But yeah, it is our code, right? And the reality of building applications today, especially with these managed services, when we look at chaining managed services together, generally the weakest link is going to be the code that we put in there, right? Now, I'm not knocking your development skills. I'm really not. In a room full of 100 people, I'll probably be in the top 50%, but I will not be the best developer in the room in any room. And I'm a pretty good developer, but we do it all day long, and we introduce bugs, we introduce problems. Whereas these managed services, yes, they are developments underneath, but they have gone through so much testing, and then as we chain them together, it really limits that. And that's true with any of the cloud providers that you are choosing to use. So what do? Okay, we can't get away from code. No, you're right, we can't. But there are some steps we can take to do this. And this is where we're going to talk about thinking asynchronously. And the idea is we're going to take and we're going to move our storage to the middle and our compute to the end. So then our API will talk to our storage, and then we have compute. And again, this is called thinking asynchronously. Well, all right. You said the words, you showed your paints and animation, and if you've ever watched any of my decks, you'll notice that I never do animations. I was very proud of that one. All my stuff builds out in slides, but what does thinking asynchronously mean? So let's break it down. It really comes to basically two things: store first, process later, or process after. Okay? So what's the advantage? Why do I want to do this? Well, as I mentioned before, one, it provides greater reliability. Okay, data is stored before my code gets a hold of it. Right? So what I'm doing is I'm saying, look, I'm going to foolproof my application to say, I think I'll store the data before I start monkeying around with it, before I start playing with it. Okay? Now, as I said before, code can kind of be the linchpin. It can kind of be the problem with our applications. So what I encourage and what I try to do on my own is I try to do less code. And this is the second advantage of this, right? So when I reduce code, I'm using, I directly integrate my services. I don't have as much code. I don't have as much areas where there might be issues. Okay? So the next thing is faster response time. So let's talk about that for a minute. As developers, web developers, application developers, any kind of developers, one of the things that we deal with on a daily basis is how can you make it faster? Now, as I said earlier, I have 5 kids. Their ages are 7 all the way up to almost 19. And I've watched them as they're playing their games, their Snapchat, their Twitter, their whatever. And the thing about technology is if I don't get instant gratification from your application, then your application is broke. It's done for. It's broken, right? That's the truth. If I can't wait 15 seconds and watch the wheel spin. We all use different services that we go, wow, I know this is taking forever. It must be broken. And what do? We repeatedly click the button. And you can't see me, but I'm acting that out. We repeatedly click that button over and over and over, or we go on, or we just give up. So you know what? I'll find another app, see if it does it better. So response time is critical in our industry. So what we want to be able to do is we want to be able to say, hey, now you maybe say, yeah, but you haven't done the compute yet. Well, you're right. But the reality of clients is they're more willing to expect a message that says, hey, we got your data, nothing's broken, we're doing the processing, and we'll get right back to you, versus wheel spinning, no communication, is it working? Did my credit card payment go through? Am I going to get double charged? Am I going to get triple charged? And then there's panic, right? So communication and instant response is a very critical thing in our industry. All right, so let's look at process after. Okay, and the primary advantage of processing after is simply we can do more. Right? Asynchronous processing makes it easier to do more in less time. Or let me rephrase that, in less apparent time to the client. Right? So we've already talked about getting an answer back to our client, hey, we're working on it. And then what I can do, and a lot of us build that, we have applications that have to do a lot of things. The application we're going to look at in a minute is going to do some translation, some audio, do some transcribing to audio. It's going to do a lot of different things. And so if I have to make my client wait while each one of those are happening, then I can't do as much because it takes too long. But if I'm processing after I store my data, then I can do multiple things. I can do my thing 1, my compute thing 2, my thing 3, my compute thing 4, my compute thing 5, and so on and so forth. So I have a lot more flexibility, and I can feed small bits of data. If I've written, even with the WebSockets or even, polling from the client, I can feed data back to the client to keep them updated because communication is key, right? But I can continue to process and work on the data. All right, so you may be thinking to yourself, okay, that's all well and good, but how does this work, right? If I don't talk to my compute, then how am I going to trigger it to do things, right? So let's talk about making this work, okay? And first of all, let's go back to our original architecture here, and let's take a step out of this and let's talk about serverless for a minute. And I'm not there to, ask and have you raise your hands, but I'm assuming you're either working with serverless or looking at serverless, okay? And when we talk about serverless, we look at, what is serverless? And the basic idea behind serverless is something happens, we react and do something. And for us, that's usually with a lambda, a lambda function, where something happens, and that something can be an IoT button gets pushed, data gets dropped to DynamoDB. Really, it's an API call is made, something's dropped in an S3 bucket. There's any number of things that can trigger a lambda. It's really kind of limited to only to your imagination. Then that lambda gets triggered and it does something. So now you're asking yourself, so what you're telling me is serverless is something happens, we recognize something happened, and then we do something? Yeah, that's what I'm saying. It's called event-driven patterns. It's all about events and how events are passed around. Okay? And on AWS, when we look at serverless architectures, and just to be clear, I am a senior developer advocate for serverless at AWS. You're going to see AWS examples here. And I will encourage you, though, these patterns can be taken to other clouds, to other architectures that you might be working for. Anytime you're working with event-driven architectures, this is something you look at. But I'm going to show you how to do it on AWS. I think it's really slick, and I hope you enjoy it. So let's look at what this looks like on AWS. So the services that we're going to talk about for a minute are Amazon API Gateway, Amazon DynamoDB, and Lambda, AWS Lambda functions. Okay, and so how this is going to work is, first of all, we have this idea of what we call the API Gateway Service Integrations. All right, so what does that mean? Okay, service integrations allow us to connect services directly together. So Amazon API Gateway, I don't have to connect to a Lambda to then talk to DynamoDB. I can talk directly to DynamoDB, and I'm not writing any code. Okay. Now, this can get debatable because when we do this, so first of all, I could communicate. AWS has over 100 plus services that we can communicate with Amazon API Gateway, and I'm going to use a templating language called VTL. And I think you might be going, whoa, hey, that's code. And you would be right. And this is something we can debate back and forth. It is code. It's templating language. And the kind of cool thing, it's frustrating and cool, is it either works or it doesn't. It's very easy to go, boom, I blew that up, that doesn't work. And so they're pretty straightforward ideas. And I would give you an example. I would encourage you to go to the AWS blog and do a search for building a serverless URL shortener. And I show a full example of actually building a URL shortener with just VTL, which is Apache's velocity templating language, on API Gateway with DynamoDB, and I cache it with our CloudFront. And there's no lambdas anywhere, and it's wicked fast. Okay, so API integration services can be very quick, and they're safe because you're storing the data first, right? Okay, but you said, all right, Eric, so now I need to trigger a Lambda function. You're telling me you've stored data in DynamoDB. How do I tell the Lambda function? Well, with DynamoDB, we have a thing called DynamoDB streams. Okay, DynamoDB streams they're a log. I mean, as you write data to DynamoDB, it creates a stream that can trigger a Lambda. So it'll say, hey, this new data was put there. Hey, this was updated. Hey, this was deleted. So on and so forth. And you can pass the actual data to the Lambda. Okay, so as data gets written, it's going to trigger the Lambda function, and then I have control over this. Now, I will tell you that DynamoDB is not the only storage first pattern or service that you can do. There are others, and I'm certainly not listing them all, but Kinesis could be used. Amazon Kinesis. Amazon Simple Storage Service, as something's dropped into a bucket, you can trigger a Lambda. Dynamo, as we talked about. Also SQS or SNS. So there's a lot of different options that you can do when you look at the storage first pattern. All right. So let's look at our application that we're going to use. In the detailed description of this talk, I said, I'm going to take an asynchronous application and convert it to an asynchronous. All right. So I'm going to kind of talk you through what's going to happen. You'll kind of see what the application does. So we're going to start first of all with our data. Okay, so with our data, with our client, and you'll see this beautiful client that I built in a few minutes, it's going to pass a string in a parameter called data, and that string is just some text. It could be any language. That's the beauty of the translation, is it'll translate from one to the other. And you say, this is the text, and then you pass a culture, an array of cultures. Okay, and those cultures say translate it to these different cultures. So in this example, it would be French, Turkish, Turkey, German, German, and Canadian, French, or French, Canadian. However you want to look at this. So I have 4 cultures that I'm going to translate this hello, welcome to my translation demo. So let's look at this in a synchronous pattern, very acceptable pattern on how you would build these out. Okay, so first of all, this is kind of an example of what a standard client-server application would look like in the serverless realm. Okay, the scope of this application is not to show all about that, but just to kind of give you an idea, is we would generally host our client in AWS Amplify, which would allow us CI/CD, caching, all the things, rewrites, stuff like that. And we would do our user pool or user authentication through Amazon Cognito. And then we would use, as I mentioned, API Gateway to front our application, and then we would use Lambda as our compute, and then eventually, you'll see as I'm going forward, DynamoDB as our storage. But we have to do some work on the data first. So when we push this data in, the first thing that's going to happen is each culture is sent to Amazon Translation as a separate request. So what it's going to do, it's going to take this data that we showed here, and we're going to say, okay, take hello, welcome to my translation demo, and ask that it be requested in French. Then it's going to say, hello, welcome to my translation demo, and make it have a request to a translation in Turkey. So there's 4 requests that are going to happen here to Amazon Translate. Okay. When Amazon Translate is done, it will then feed the data back to the Lambda function, and the Lambda function will take each of those strings. So I now have really 5 strings. Okay. I have the original English, and then I have the 4 translated ones: French, Turkish, German, and French Canadian. And it's going to pass those to Amazon Poly. Okay? Amazon Poly is then going to take that text for each one and convert it to an MP3 file. So at the end of the day, I'll have 5 MP3 files. Okay? So once those are passed back as a stream to the Lambda function. It buffers those back, and it takes those and writes them as MP3 files to an audio bucket, or an S3 bucket that I've entitled my audio bucket. And finally, once S3 says, yep, I've saved those, all 5 of them, then we write the data to DynamoDB. Okay? And when it's done, then this is what our data will look like, right? So I've got my original, and then I've got and I'm sorry, the English won't be translated. I don't actually translate the original, just the translations. So then I've got my 4 audio translation links, and then I've got my 4 translation texts, okay? And then down here on the bottom, I have my S3 bucket that shows the MP3 files stored as well. Now let's evaluate this for a minute. Looking at this, like I said, this does work. In a happy path where nothing breaks, this works fine. But what's the reality of applications? The reality of applications is something's going to break at some point. At Amazon, we build our services to be resilient. There's no doubt about it. But we're wise enough to understand that sometimes things will happen. So not only do we want to build in resiliency, we want to build in redundancy. We want to build in the ability to degrade gracefully, right? And then we pass on services, or the ability to do that to our clients as well. So let's take, for example, what if my translations go through and I say, okay, translate all 4 of these and I get them back fine. Then I say, okay, translate them all to audio files and I get those back. So now in my Lambda, I've got all my audio files and I've got all my text translations. Then I go to save it all to S3, and something in my code tanks, and it doesn't work. And my retry fails because it's the same error. Well, here's what's happened. Now, I've got the translations, I've got the audio files, I couldn't save them, everything tanked, and I don't have the work done for my client. But not only do I not have the translations available to write to DynamoDB, I have to go back to my client and say, hey, you know that job you requested? Yeah, I didn't get it done, and I lost the original request. Is there any chance you can give that to me again? And it makes me look silly. We're losing credibility with our clients. So what we want to do is build our application that that doesn't happen. Now we've kind of talked through that, so let's look at a demo and see what that looks like. All right, so I'm going to go over to my application. Now, here's the truth. I built this design. I'm not gonna lie. I started as a designer, and you're probably asking yourself, "Oh my goodness, how could you possibly be a designer?" Yeah, you're right. So this is a very simple design, but it gets the idea across. Okay. So I was building this out earlier. You can see some different things here. Welcome to GOTO Oslo, and you can see, and I'm on the synchronous version. I'm not in the asynchronous version. You can see the different translations of what I had here, and you can play these. Now, again, if you saw that link, and I'll show it again, you can actually play these when I'm in the room with you. I can play them for you, but not the case here. So let's go ahead and make a new one. Okay, so we're going to do that, and we had some heroes announced. I've already done one for Ben. Let's do one for, let's do this one here in Lagos, Nigeria. So we're going to copy his data, and we're going to say we want to translate this whole thing, and we want to translate it to every available language. So I'm going to select all, and then I'm going to hit translate. Okay, well, I've got these three little dots. That's good. Oh, okay, something's working. That's great. Yeah, it's working, right? Oh, maybe it's not working. Uh-oh, something's broken. Is my internet? Oh, okay. Whew. Okay. That wasn't too bad. A little slow, maybe a little nervous, right? But I could click in here. Okay, all right. Here's everything. I've got the translations. Everything's going good. All right. I've got the files. I can play those. Okay, so that wasn't bad, but I had to wait about 5 seconds or so. And you may be thinking to yourself, well, okay, 5 seconds, Eric, that's not a big deal. But that was a pretty short piece of text. Let's go back to the text for a second. Look how short this is. What if I was doing, chapters of a book? I would get pretty, I would say, translate a chapter of a book to Arabic, Mandarin, and Danish. That would it's going to time out. And I can set my timeout up to 15 minutes in a Lambda function. But that's pretty costly, isn't it? If I'm running every time my Lambda fires, I'm going 15 minutes. Yeah, there's got to be a better way to do that. And there is. Or, I wouldn't be up here standing and talking this. So let's go back to our demo. And I'll give you just a minute. This is in fact, this is built on that URL shortener that I told you about. If you'll go to slip.link/translate, you can play around with this application. Now, I do delete the translations out for a while, so I'm not paying for a bunch of storage, but feel free to play around with it, see how that works. All right, so let's take a look at that same application, but in an asynchronous manner. Okay, so what will that look like? So let's go back and let's start again. Okay, same thing. We're hosting on AWS Amplify. We're hosting our client. We're doing authentication through Cognito. But this time, instead of writing directly to a Lambda, we're going to use that service integration. We're going to write directly to Amazon DynamoDB. Okay, so this is the original request. It's written to DynamoDB. So what happens? Remember, I talked about the streams. Okay, so we're going to take and we're going to say, I'm going to output a stream, and I'm going to have one Lambda function. His entire job is to just read the stream. Okay, so he takes and those streams and he breaks. He says, okay, you got some translation. You got an original one. It's got 4 cultures. I'll break those out into requests. And I'm going to push that into Amazon Event Bridge. Okay, now Amazon Event Bridge, a service we haven't discussed yet. Amazon Event Bridge is it's an event bus, and it can handle massive amounts of events flowing through it in seconds. Trillions of events cruising through it, and then you write rules to trigger lambdas. Okay, so in this case, I'm going to push 4 requests in. I'm going to push the text and say I want these to be translated to these 4 different cultures. So what's going to happen is I'm going to write a rule that says, hey, anytime you see a translation request, trigger this Lambda function. That Lambda function will then take and make the request against translate and then write the data back to DynamoDB. Okay, so just those rules. Okay. Now remember, if we have something going into DynamoDB, well, then it's kind of a circular pattern. It's going to go into the stream. Our stream reader reads it and says, okay, these have been translated. So the next step is I need to do audio transcribing. So I'm going to write another rule that says, hey, so the stream reader is going to push audio transcribe requests into Event Bridge, and I'm going to write another rule that says, hey, when you get an audio request, trigger this Lambda, and then send that data to Amazon Polly. Now, Amazon Polly will take text files of multiple languages and convert them to audio files, and what I want are MP3s. But the cool thing is, I could say to Polly, okay, I'm going to sit here and wait for the buffer, like in the previous example. But instead, because I don't want to just spin my Lambda, there's really no reason to. How about when you're done, you just drop that audio file into a bucket for me? And Polly says, yep, I can do that. Okay, so all we do is we quickly send the text. So you're talking millisecond request times here on these on the lambdas you're seeing so far. Very small footprints on these lambdas. Boom, they're up and gone. Right. So Amazon Polly churns on those, creates the MP3 files, drops them into a bucket. All right. Well, this is great. So what happens if I did the translates, and then I try to do Amazon the audios and it crashed like an earlier one? Do I lose everything? No, because my original data is still in DynamoDB. So I can write in some logic to test that. We'll talk about that in a few minutes. Okay? All right, so once the audio files are dropped into a bucket, it then triggers, per audio file, another Lambda called I'm calling my finalized Lambda. Okay? And the bucket then triggers that, and that then takes the data and writes the final records back to DynamoDB. Okay, so now I've got 4 lambdas, and you may be asking yourself, well, wait a minute, 4 is more expensive than 1. Well, not necessarily. If you remember, the other one had to run for 5 seconds or more. It ran for a pretty good amount of time. Okay, 5,000 milliseconds, right? Whereas the stream reader is going to, that's probably, that's a couple of milliseconds. Maybe let's say 50 milliseconds for each one. Right? Translate. That's a quick boom, 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 boom. Send these in, get it back, because translate happens very fast. Audio file, all I do is send the text. I don't wait for a response, so that's very fast. And the finalize, I'm just getting some data and writing it to DynamoDB. So you've actually reduced the amount of time that your Lambda runs. And when you're billed for Lambdas, you are billed on invokes, so the number of invokes, but you're also billed for the amount of time your memory is used. And so you're hugely reducing that by going this route. Okay, so let's look at an example of what we just did. I'm going to drop out again. Okay, so now I'm going to go back to the home, and I'm going to bring up and actually let's grab the same one so we can apples to apples. Okay, so we're going to go to home. We're going to convert to our asynchronous API. And all this is doing is just literally changing the API that the application hits. This one hits my synchronous architecture. This one hits my asynchronous. We're going to create a new one. Paste that data. Once again. Now, last time I clicked this, we were 5 seconds or more. So I'm going to give it a shot. Let's see what happens. And, whoa, that was really fast. Okay. Now, look here. I've got all my translations. And if I didn't, they would load in. But I let my customer know, hey, your audio's rendering, and it will be here shortly. They don't mind seeing that. Now, if this sat there all day, I'm like, okay. But they're willing to give this some time. Audio rendering, I get that. That might take a little bit. And all I'm doing, I could do this through sockets, but all I'm doing is I'm polling the application. And there it popped in. You can see that it now works. Okay, so there's all my data. And yes, the overall amount of time was actually probably just a pinch longer because I ran it through the system, but the amount of time my customer was waiting was much less. They were, I'll peruse the translations, and okay, the audio files are in, and I can listen to it. Okay, so I didn't stop my customer from working. They didn't have to sit there and watch, and more importantly, I've instilled confidence that this thing isn't broken, right? So there you go. So let's go back to our demo here. Alrighty. Don't look ahead. Okay. Alright, so there it is. Slipped out link /translate. If you want to play around with that, please do. Looking forward to seeing, give me feedback. So, the last thing here, or let's moving on. What if we want to add even more reliability? Okay, like, wow, Eric, you've built a very reliable system. Well, thank you. I appreciate that. But there's still more we can do. Okay, so let's go back to our application and evaluate this. So when we're looking at the application, this is what we built so far. And when we look at this, we say, you know what? We have 4 different lambdas right now. And the fun thing about these is each of these handle a different piece of code, but they also handle error handling. And the error handling is probably going to look somewhat similar. Hey, this didn't work. In my instance, what I do is I actually write back to DynamoDB all the same data except for the resulting, computed data that I needed, I put an error. So I'll actually flag it as an error so later I can look for that and then see, okay, what happened. Right? So here I've got, here's 4 pieces of code, 4 pieces of error handling, but those 4 pieces of error handling probably pretty close. So what if I could roll those off to another lambda? Okay, so instead of me handling the error code, and this idea, if you've never heard this, is called dry. Don't repeat yourself. If I'm doing the same error handling on all 4 of these lambdas, why don't I centralize that and make another lambda handle that? And so we have this really cool thing we announced last reInvent called Lambda Destinations. And the way this works is I can run a function, and if it's successful, then I can trigger some data into EventBridge, Lambda, SNS, or SQS. Or if it's on fail, I can then trigger data into the same data. Right? I can set the maximum age and number of retries on my Lambda, and I can just say, you know what? Only try it once. If it fails, send it somewhere else. Okay? So in this example, I'm going to use a Lambda. I mean, really, you could do this all kinds of different ways. And for the moment, just for our example, I'm just going to worry about errors. Okay? So what's going to happen with this is if my stream reader fails, it's going to send data to my error function and say, hey, I failed. You deal with it. Same with my translate, my audio, and my finalize function. And so the errors lambda says, okay, I can deal with that. So let's put this back into our architecture. Okay. So what the error function does is he then writes to DynamoDB and says, hey, this ID tried this action and this was the result, and I'll write, I'll save the error data or something like that. Okay. So now I've got that data saved and I can say, all right, well, I want to evaluate that. Okay, so when we're looking at that, if I've written that data back, then I can start looking at some, and this is probably, I want to be cautious when I use this term, but kind of some self-healing or application healing logic, right? So what if I introduced a lambda that's an error correction lambda? Okay, so I can have this lambda that reads DynamoDB on a cron basis. I can say, hey, every 10 minutes, look for any errors and try it again. And if it fails, and then keep a count on that. And if it's the second time, then notify someone. Let's see what's wrong with it, or let's write some logic to see what we can figure out, depending on how you want to approach this. Right? So he can check that, do a scan on the database, which isn't something you want to do all the time, but you can do a quick scan. There's some database magic you can do this where you can do some partial indexes, things like that, or sparse indexes, I'm sorry, to write those out. So a lot of power you can do with this where you can say, look for errors and let's do something about that. Okay? So hopefully you're seeing there's kind of a pattern building up here, right? Okay, and so the first thing we said, look, we're going to store the data in DynamoDB. Again, you can use SQS, Kinesis, whatever. In this one, we're going to store the data in DynamoDB. Then we're going to, with our stream lambda, we're going to analyze the request and insert it into event bus. And then we're going to, and this is where the pattern really starts. We're going to create rules to trigger a specific lambda function to handle a job, and translate, poly, something else like that. Then we're going to write the data back to DynamoDB. And if there's an error, we're going to send it to the error lambda function. Okay, and so when we take this and we say, okay, now we've got this much built. We want to build this application bigger. We want to do more, right? So let's extend this via the pattern we just looked at. What we want to do, let's say our customer says we want to understand the sentiment of the content being translated. So if someone puts a big old long paragraph in, we want to know if they're happy with us. We want to know if they're mad at us. We want to know if they're sad or whatever. Okay. So we have this wonderful service called Amazon Comprehend that will analyze text and say, hey, this person's mad at you. You might want to do something. Or, hey, she loves you. Or, hey, whatever. He loves you. Whatever. Okay? So applying our pattern, let's see how we can add this service into our application. Well, first of all, we know it's going to get written to DynamoDB. We're storing there, and StreamReader is going to insert that into EventBridge. At EventBridge, we're going to create a new rule that says, hey, every time you see a sentiment request, or we might just do it on the original or however we want to do it, then trigger the sentiment Lambda, which will then talk to Amazon Comprehend and get the data back and write it to DynamoDB. Or if it fails, write it to the error handler. Okay, so I can continue to add more services to do more things with this by just simply write a rule, trigger a Lambda, talk to the service, all errors or all data goes back to Dynamo, all errors go to the error handling function. Immense amount of power here, but done very quickly. Okay, and so the end result, this is what our application looks like. Now, don't let all the lines scare you because I'm trying to show a lot of different things, and hopefully I've explained that properly. But the reality is we're keeping it very simple. Each of these lambdas do one thing, and they do that one thing really well. They don't even do error handling anymore. So the code, the lines of code are probably in the neighborhood of maybe 20 lines of code or less for each lambda. And then, my error handling is going to do some logic. So it's very small bits of code, and there's single responsibility. And then I'm tying into serverless. So if you haven't figured out, serverless is very much, yes, we have code in Lambda, but that's just part of it. There's so much you can do by simply using the managed services and chaining those managed services together to accomplish the goal you're trying to accomplish. So thinking asynchronously is huge. So let's wrap up and kind of talk about this. Like I said, thinking asynchronously, that's the first thing. Where can I push off processing so my client's not waiting for it, right? Put storage first. That's going to help you a lot with that. When possible. I'm not someone who's standing up here saying, hey, look, every time there shouldn't be an application as storage first, but I would tell you that you could probably do a lot more than you think. Okay, and finally, use less code. Chain these services together. Let them work for you. Integrations and API Gateway is a great glue for that. There's some others you can use, but API Gateway integrating with backend services directly is extremely powerful. All right, so let's look at if you want to get started with this. A great place is to, if you've never used serverless, hit aws.amazon.com/serverless. It's a great place to kind of jump into that. I would also encourage you to, if you get a chance, please remember to rate this session. We want to know how we can do better. I know that this is a little different than most of the go-tos, and if you're like me, you absolutely love the go-to conferences. So not being there in person was a bummer, but I appreciate what they've done here and that they kept it virtual and they kept it going. So, again, my name is Eric Johnson. You can reach me at EDJ Geek. I'm going to try to be in the Q&A, so hopefully we'll be doing Q&A just shortly. But if you can't, if I'm not able to be there or something happens, then hit me on my Twitter. Glad to answer questions. And I hope that you have a great day. If you're on the cruise, man, safe travels. I hope you stay healthy. I hope you're having a blast. Have a Diet Dr. Pepper for me. If you're not on the cruise, stay safe, stay healthy. Have a great day. Blessings. We'll see you later.